Hello everyone, welcome back to another episode of All Things Math, a series where we break down seemingly complicated topic into easy to digest videos. This week we will be talking about a very important topic that is applicable in mathematics, science, humanities, and in pretty much all areas of discipline that deals with a lot of data: statistics. Defined by the Merriam-Webster's dictionary, statistics is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. Take a look at this map showing the worldwide increase or decrease in temperature in various regions of the world. You can see that there's a lot of data collected for the entire world. The data on its own can be useful for regional lawmakers to decide on what to do. However, to effectively combat climate change, a global action is required, which is why we need measures of central tendency. There are three types of measures of central tendency: the mean, median, and mode. Let's begin with the familiar, mean, which is a fancy word for average. The way we calculate average is to add all the data points and divide it by the number of data points. For example, say we have 5 numbers, 1, 2, 3, 4, 5. The average of these numbers are the sum of all the data points, in this case 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15, divided by the number of data points, which in this case is 5. This means the average value of the dataset 1, 2, 3, 4, 5 is 3. Let's see how this can be applied to our global warming example. Firstly, we can divide the world into regions or squares. Then, we can take the increase or decrease value of regional temperatures and find their sum. After that, we can divide it by the number of regions that we initially set. The higher the number of regions we initially set, the more accurate the outcome would be. To skip the calculation bit, the source has kindly provided us with an average increase of 0.84 degrees Celsius worldwide. That value doesn't seem much, does it? However, remember that 0.84 degrees Celsius is an average of worldwide increase and decrease in the temperatures. This means there are regions across the world that are experiencing extreme temperature increase which are higher than the average, such as North America, as well as regions experiencing temperature decrease such as the Pacific Ocean due west of South America, which brings the average down. The average or mean cannot paint the full picture of the condition. However, it is still useful in indicating that there is an increase in global temperatures. Sometimes, however, there are cases when taking average is not really useful in depicting a situation. Take, for example, income distribution. The following graph displays how income level varies across the world. Let's break down this graph. The blue curve shows us how many percent of the world population is earning how much in 2013. At its peak, slightly more than 0.8% of the world population is earning about $550. Meanwhile, less than 0.1% of the world population earns more than $10,000. If we were to calculate the average income of a person in the world, the result wouldn't necessarily reflect the condition of most people. This is due to the fact that the high-income earners are able to pull up the global average of income earners by a lot, even though there are so little of them. Thus, by looking at the average income of a person in 2013, it would not necessarily reflect the living conditions of most people. As a solution to this, there are two solutions that we can adapt. The first and more simpler solution is to look at the mode, or the data point that appears the most. In this case, around $550. This would be a more accurate representation of the living condition of most people. Another solution that we can take is to find the median. The way the median works in this case is if we were to line up all the people of the world in a row according to their income, what would the person in the middle earn? That is the value of the median. The graph has kindly provided us with a median of $2,010 in 2013, which is a more accurate statement of how an average person might earn at the time. To compare median and mean, take a look at this table that shows the difference between the median and mean income of different countries. The value of median, as seen in all the data points above, are much lower than the mean because median seeks to find the mid value of all data points, and thus the high or low extreme values will have less impact on the value of the median. To compare median and mode takes in the most frequently occurring data point, which ignores the nuance that a dataset can have. Some datasets might have 2 peaks, while mode only takes one with the highest frequency. Take, for example, the following chart, displaying the peak hours of quick service restaurants. We can clearly see that there are 2 peaks when a large number of customers rush into the restaurant. In this case, although we can take the mode, which stands around 12 p.m. with around 15% of the daily customers walking in, we can't ignore the fact that there is another peak at 6 p.m., which is also where a significant amount of customers walk in. To make this data useful for restaurant owners, simply taking the average or median would not be enough, since both mean and median will result in timing other than the peak. Taking the mode would also not tell the whole story, since we will cut off the dinner rush hour. This is a classic case of multimodal distribution, or basically a graph with multiple modes. In this particular graph, there are 3 modes, one at 12 p.m., another at 6 p.m., and a shorter mode at 9 a.m., which corresponds to the lunch, dinner, and breakfast times respectively. Thus, we have concluded that 9 a.m., 12 p.m., and 6 p.m. are the times where restaurant owners can expect a large traffic into their businesses. The mean, median, and mode are what we call measures of central tendency, since they measure the central value of a distribution, which is a fancy term for a dataset. However, as you can see with the example of multimodal data, sometimes looking at the central tendency of a measure doesn't really capture all the nuances of a dataset or distribution. For example, we can see that the median income worldwide is less than the mean, and that tells us that income distribution is skewed. However, to what extent is it actually skewed? Is income really unfairly distributed, or is it not very skewed, which may suggest a fluctuation of the market? To see this, we can take a look at quartiles and interquartile range. Quartile, as the name suggests, divide a dataset into 4 equal quarters. To determine quartiles, arrange your dataset in an increasing order and find the median. The first quartile is the median between your first data point and the median. The third quartile is the median between your dataset median and the last data point that you have. To illustrate, say you have 7 data points, 1, 2, 3, 4, 5, 6, 7. The median in this case would be 4. And the first quartile is 2, since it lies exactly halfway between 1 and 4, inclusive of 1 excluding 4, and the third quartile would be 6, since it lies exactly halfway between 4 to 7, inclusive of 7, exclusive of 4. The interquartile range is simply the difference between the third and first quartile. In this case, it's 6 minus 2, which is equal to 4. The larger your interquartile range is, the more widespread your data points are. You can also see whether your data is skewed or not by looking at the difference between the quartiles and the median. If the difference between the first and second quartile or the median is less than the difference between the second and third quartile, this means that your data is skewed to the right. Take for example the following data points, 1, 2, 2, 3, 5, 6, 7. The difference between the first quartile and the median is 1, and the difference between the median and the third quartile is 3. This shows us that the dataset skews to the right. In another database, 1, 2, 4, 5, 6, 6, 7, the difference between the first quartile and the median is 3, while the difference between the median and the third quartile is 1. This shows us that the dataset skews to the left. So today, we've learned statistics, what it is, how to use it in the real world, and how to evaluate large datasets. There are more statistics than what is covered today, and I do hope that this video ignites your interest in exploring more about statistics. Don't forget to click like and subscribe on your way out, and we'll see you soon.